This handout is going to go over how to calculate comparative advantage. Make sure you understand the difference between absolute advantage and comparative advantage, because absolute advantage, all you're doing is looking at these numbers and seeing if it's an output question, who can make more, and if it's an input question, who can do it faster or with fewer resources. This one is an output question because we're looking at the same amount of time. We're looking at for a week of labor. So in 1 week, we're looking at how many potatoes and cabbage that Anna and Barry can produce. And so right here, this is an output question. And you need to make sure that you put in your notes somewhere the formula for output and the formula for input. So output, the formula is other goes over, and I remember that for output and over, they both start with O, so that's how I remember that. If it's an input question, other is going to go under. And so as we work through this, hopefully that makes some sense. So this is an output question, so the other is going to go over. And we're going to come down here and read the question. So Anna's opportunity cost of producing a unit of potatoes. And so we're looking at potatoes, and here is your chart. If potatoes is what we're talking about and trying to figure out, the other is cabbage. And since this is an output, it's going to go over. And so all I do is put down 100, and then at cabbage is the other, it's going to go over. Make sure you're using your calculator so you're not making any stupid errors. But this one is pretty easy. That's just 2. And so if we're looking at Barry's opportunity cost of potatoes, once again, the other is cabbage, so it goes over 150 over 120. Put that in your calculator and you get 1.25. And so what you're looking at here, we can tell that Barry has the absolute advantage in making potatoes because in 1 week he can make more, and that Anna has the absolute advantage in making cabbage because she can make more in 1 week. This goes to that question, and this one is pretty easy because we can see that clearly one has the absolute advantage in one and the other has the absolute advantage in the other. So where this becomes tricky is when the same person or the same country or the same company has the absolute advantage in both. So this one's pretty easy. What we have to do is look at the opportunity cost. Who gives up the least? And so in producing potatoes, since Barry only gives up 1.25, he has what's called the comparative advantage. Looking at the other part of this problem, Anna's opportunity cost of producing cabbage, so you're just going to have to look back at that chart from the previous page. And the other nice thing about this is once you've done it for one, it's just the reciprocal or the opposite. So since Anna's opportunity cost of producing potatoes was 200 over 100, now we're looking at cabbage. Now potatoes is the other. So potatoes goes over, and the same with Barry. His opportunity cost of potatoes, we put 150 over 120. Well, now we're looking at the opportunity cost of cabbage. So potatoes is the other, and now it goes over. And so if you put this into your calculator, you should get 0.5 for that and 0.8 for that. And since 0.5 is less than 0.8, Anna has the lowest opportunity cost in producing cabbage, so she has the comparative advantage. So it says who has the comparative advantage in producing potatoes. We're going to look back at the front page. Barry's opportunity cost is 1.25. Anna's opportunity cost is 2. His is lowest, so Barry should be making potatoes. When we look at the opportunity cost here of producing cabbage, since Anna has the lowest opportunity cost, she should produce the cabbage. Down here, this one is Henry and John, and once again, we're looking how many can they catch in 1 day. So they're both using the same amount of time. So this once again is an output, and so the other is going to go over. So Henry's opportunity cost of bass, catfish is the other. So Henry, and we got to look at it this way, catches 6 catfish and 4 bass in 1 day. And so if you put that into your calculator, that comes out to 1.5. John's opportunity cost of catching a bass, catfish is the other, so it goes over 12 over 24, and that's the same as 0.5. We're looking at the opportunity cost of catching catfish. Now bass is the other, so we're just going to flip these numbers over. 24 over 12. So this comes out to be 0.67 or 0.66 repeating and 2. So we're going to evaluate for bass who has the lowest opportunity cost. Since 0.5 is less than 1.5, John has the comparative advantage in catching bass. And then down here, 0.67 is less than 2, so Henry has the comparative advantage. But the interesting thing about this is when we look at how many fish can be caught in one day, John has the absolute advantage in catching bass, and he has the absolute advantage in catching catfish. But when we do the comparative advantage, and this is extremely important, you have to know that even when the same person has the comparative advantage, or excuse me, the absolute advantage in producing, they still benefit. By doing what you do best at the lowest opportunity cost, both of you are going to benefit. You're both going to catch more of, John will catch more bass than he would have had he been trying to catch both. Henry would catch more catfish than if he was trying to catch both. And then what you have left over, you will trade. So even if you have the absolute advantage in producing, you still benefit from trade. Focus on what you do best with the least opportunity cost, and then everyone trades, everyone is better off. The next one, we're looking at one plane. So we're not looking at an output now, we're looking at the number of days. So this is an input problem. They're saying in one day, excuse me, we're looking at to produce one car, it takes ABC Corporation 8 days. To make one car, it takes XYZ 15 days. So instead of making more, now what we're saying is ABC can make it in fewer days, so they have the absolute advantage. And if we're looking at how long does it take to make one plane, ABC can make one plane in 10 days and XYZ can make it in 12. So once again, ABC is using fewer resources, fewer days to make it, so they have the absolute advantage in both cars and planes. But we know that by producing what you produce at the lowest opportunity cost and then trading for everything else, both of you will benefit. So what we're going to look at here is the opportunity cost of producing cars. Since this is an input question, other is going to go under. So other is planes, it goes under cars. So 8 over 10. And then for XYZ, the other is planes, so it's 15 over 12. Oops, that's a 12. So this is going to be 0.8. This is going to be 1.25. And then we're just going to flip it. For planes, cars is now going to go under. So it's 10 over 8, 12 over 15. And so now we have 1.25 here and 0.8 here. And so when we're looking at who has the comparative advantage in producing cars, it's whoever has the lowest opportunity cost, and that is ABC. And down here, who's going to produce planes? XYZ has the lowest opportunity cost, so they're going to produce that. This next one has an added step that we're not going to do, so I'm going to go ahead and skip that one. We'll go on to this next one, where we're looking at olives and olive oil. Let me move this down a little bit so we can see everything. There we go. This is an output problem because it's how many cans and how many bottles can they produce. And what we're going to do here is, since it's output, other is going to go over. This one is going this way, so don't let that trip you up. It doesn't matter where. These are the two products we're talking about, so we're going this way.
Just a reminder this morning that all 10th grade students will be meeting for I-STEP testing this morning. Also, juniors who are retaking English will report to your testing areas as well. If you're in the building, please report to Mrs. France in the cafeteria. Deanna Wilcox, Kyla Chapman, and Caitlin Dobb.
Okay, sorry about that. So we're looking at olives, so olive oil is the other, and since this is an output, it's going to go over. So 10 over 60. For Columbia, the other is going to go over, so olive oil over 24, which is olives, and then we're just going to flip those. this right here is 0.16. This here is 0.33. Then we have 6, and then we have 3. So we're evaluating here who has the lowest opportunity cost in producing olives. It's Zaire. And who has the lowest opportunity cost here? We're going to focus on what we do best and then trade so each one of us are better off. And then the last one here, this is how many hours it takes to make one television and one computer. So this is an input question, so the other is going to go under. If we're looking at television, computers is the other, so it's going to go underneath. So what we're looking at here is 18 over 6. And then for blue land, the other is computer, so it's going under, so 16 over 4. Then we're going to switch that up here, 4 over 16. So this ends up, when you put it in your calculator, 3. This is a 4. This is 0.33. And this is 0.25. We're going to see who has the lowest opportunity cost, and that's red land. Down here we're going to see that it's blue land who has the lowest opportunity cost. So once again, when you're looking at output, it's who can make the most. When you're looking at input, it's who does it in the fewest hours or the fewest inputs. If it's output, other is going to go over. The two O's go together. If it's an input, other is going to go under. You're going to look and see who has the lowest opportunity cost in producing that product, and that is the one that is going to produce it.
Terry Beechler, please report to the front.